Hello and good day. Today in Pre-Algebra we'll be going over CO2, which is basically expansive of what we talked about in CO1. In CO1 we classified numbers as rational or irrational. It turns out that rational number set has more to it. Okay, they are called whole numbers and integers. Right? Kind of break it down even further here. So let's put the pen down, scroll down slightly so we can get this picture in here as well. Does anybody know what a whole number is? Well, first of all, actually, let's go back and let's define a rational number. What is a rational number? If you're unsure, flip back a page. Look at CO1. Yes, Ifan. Okay. I do want you to write that definition a second time. Whenever you write something down, not only are you thinking about it, you're writing it, you're reading it, it just sticks better. So a value with a decimal that ends or repeats. Okay? A value with a decimal that ends or repeats. So that includes a lot of things, right? It includes positives, it includes negatives. We talked about fractions being rational also. So there are other categories within the rational number system that get a little bit more specific, okay? And we're going to actually work our way up here from rational number. Let's go to integer. Does anybody know the definition of an integer?
Basically just a number.
Okay. That's true, but what characteristics are specific to integers? So such that, every integer is a rational number, but not all rational numbers are integers. What's the difference between an integer and a rational number? Yeah? It can be negative. Anybody know what it can't be? Or are we all going to learn something new today? Yeah. It can be a negative number, okay? So let's just say, so an integer is a positive or negative. It can be either. But here's the kicker. Non-decimal and non-fraction. Okay? So any decimal is rational, like 12.5. 12.5 is rational because the decimal ends, but it's not an integer because it has that decimal, has that 0.5. Okay? A number like negative 10 is rational, and because it's not a decimal, even though you could write it as one, right? We talked about that, but it's not considered a decimal, that would be an integer as well. So an integer is a positive or negative non-decimal, non-fraction. Even more specific than that, let's get a little bit smaller here. What's a whole number? Anybody know? Yeah? It's not a decimal. It's not a fraction. It's also not negative. Okay? So whole numbers are only positive, non-decimal, and non-fraction. Okay? So we start with a pretty large group, like, right? Rationals. Rational can be positive, can be negative, can be decimals, can be fractions, can be pretty much anything. Then we kind of make it a little bit smaller. And we say, okay, integers can be positive, can be negative, but can't be a decimal or a fraction. Then we get even smaller. Whole numbers, only positives. Can't be negative, can't be a decimal, can't be a fraction. Okay? And then the fourth category that's kind of separate from all of these, the irrational numbers, those are numbers that, what? And again, if you're not sure, flip back a page to CO1. Those irrational numbers. Different from all the other three, yeah. Right, a value with a decimal. Decimals that don't end or repeat. So what comes next now is called a graphic organizer, right? We like pictures. I like them anyway. Okay. We've got this giant rectangle here, which is kind of separated into 3 rectangles inside of the one. The most outer category is a rational number. Give me a value that is a rational number only. A rational number only. So not an integer, not a whole, but is rational. -12, okay? Sorry? Okay, let's talk about -12. Let's look through our definitions again. Is -12 a whole number? Definitely not, right? Because wholes are only positive. -12 is negative. Is -12 an integer? Well, it's a negative, non-decimal, and non-fraction. So -12, we would actually put that one in the integer section. Notice that this integer section is part of the rational number rectangle as well. Because -12, it is an integer, but it's also rational because it fits that definition too. It's not part of the whole number section. Give me another value. Can be anything. Your favorite number or fraction. Yeah.
0.
0. Good one. 0. Where does 0 fall here? Does it go in the outer rectangle because it's only rational? Does it go in the integer level here because it's an integer, which means it's also rational? Or does it go all the way in the whole number section to show that it's a whole number, an integer, and rational, right? The further into the center of the rectangle we get here, the more specific we are. Let's start at the top. Is 0 a whole number? Is it positive? Is 0 positive? It's not. Is it negative? It's also not negative, okay? So 0 is a very good choice. It's not positive, it's not negative, but it is a non-decimal or a non-fraction. So 0 would also go in that integer section. It's the one number that we have that does not really have a sign. It's a neutral number. Another one. I'll give it to you. How about 7.9? 7.9. Is 7.9 a whole number? No, because it is a decimal. Whole numbers are not decimals. Is 7.9 an integer? No, because it's a decimal. Integers are not decimals. Is 7.9 rational? Yes, because the decimal ends. So 7.9 would go out in this most outer section. It is rational, but it's not part of the integer set. It's not part of the whole set. How about 100? Is 100 a whole number? Yes, it's a positive non-decimal. Because it's whole, it's also an integer, a positive non-decimal. And because it's an integer, it's also rational, a decimal that ends or repeats. So 100 goes all the way in the middle here. Okay? It's a whole, it's an integer, and it's rational. You can think about it kind of like, you are a 7th grade student who is a part of the middle school that is a part of St. Vincent de Paul. Is every student at St. Vincent de Paul a 7th grader? No. So that would kind of like be the rational numbers here, right? Is every student in the middle school a 7th grader? No, so you have 8th grade also, right? So that would kind of be the integer section. And then you have you folks in 7th grade, you would be the whole number section, right? You are a part of the middle school, which is also a part of St. Vincent de Paul. However, not everyone at St. Vincent de Paul is part of the middle school or part of 7th grade, right? That's kind of the relationship that we have here, okay? And then, of course, you have the irrationals, which would be like those students who attend a different school altogether, because there's no similarities between a rational and an irrational number, right? This would be, oh, why is it writing in green? It's supposed to be red. That would be like pi, okay? Separate from everything else, right? Does that make sense? Kind of that relationship? Okay, all right. Well, we'll see if it does. Let's scroll down the page and get some questions here. It says classify each number as a whole number. Oh my goodness, whole number, integer, or rational number, or irrational number. List all applicable categories. So a number like 65. What categories is 65 a part of? Is 65 whole? Yes. Positive non-decimal. Because it is a whole number, we automatically know it is also what? An integer. And also what? Rational. Right? Every whole number is also an integer and also rational. 65 fits all three of those categories. Negative 12.7. Is negative 12.7 a whole number? No. Why not? Because it's a decimal. Very good. Is it an integer? No, it is not. Why not? Because it's a decimal. Is it rational? Yes. Why?
Because it ends.
Because the decimal ends. So you would not write whole, you would not write integer, you were just writing rational. Negative 1. Is negative 1 a whole number? Does it fit that definition? No, it does not. It is negative. Is it an integer? Yes, it is. Right? It's a negative, non-decimal, non-fraction. So it is an integer. And because it's an integer, we automatically know it is also what? Rational. If you write a W or an I, you better also write an R. Okay? Because those are part of that number set as well. So kind of a similar situation to what you had in CO1 as far as this section here, you're classifying. Okay? Are there any others here of these 12 that you want to talk about specifically? Yes. The last one, yeah, 5 and 7/7. What value does 5 and 7/7 have? Do we have an opportunity to rewrite this as an equivalent value? What is it? 6, right? That 7/7 represents another whole. 5 plus 7/7, or 5 plus 1 whole, equals 6. So really, we're classifying the number 6. Which category or categories does 6 fall into? Yeah.
Whole number, integer, and rational.
It's all three. Whole number, integer, and rational number. Okay? Just a reminder that you need to be looking at the value, not necessarily the number that you see, but what value does that have? In this case, it has the value of 6. Good? Okay. Second page of your homework. Let's scroll down here. It says answer each question. Some questions may be Not possible. Let's do the first one together here. What is a rational number that is not an integer? What's a rational number that is not an integer? Think about the definition of a rational number. Think about the definition of an integer. I want a rational number that is not an integer. Negative 12.7, sure. We talked about that one earlier, right? Why is it rational? Because the decimal ends. Why is it not an integer? Because it's a decimal, right? So this is where you really get to think about those definitions of each category and say, where does this number fit in and where does it not? Okay? The next section. Oh, man. I'm used to somewhere you can just kind of scroll down on the page. This one you got to be accurate. Live teaching, you got to love it. Okay. Determine whether the statement is always, sometimes, or never true. Always, sometimes, or never true. An integer is a whole number. Is an integer always a whole number? Sometimes a whole number? Or is an integer never a whole number? Again, think about your definitions here. An integer, is it always, sometimes, or never whole? Sometimes it is, right? Give me an example of an integer that is a whole number.
6.
6 is an example of an integer that is also whole because it's positive. Give me an example of an integer that is not a whole number.
0.
0, right? Or anything that is negative. Okay, negative 6, negative 5, negative 10. Okay? So always, sometimes, never for those here. Then the brain buster down at the bottom says, you and your parents are gathered around the TV one night watching the Discovery Channel, and suddenly you lose your satellite signal. Not being used to interacting socially, things are a bit awkward. Then you get an idea for a game. Each of you will take turns saying a number from one of the categories listed above. You can only say numbers that are rational. Your mom can only say numbers that are integers, and your dad can only say numbers that are whole numbers. The winner is the person who can say numbers from their category the longest. So whoever runs out first loses. Okay? Assuming you are each familiar with the categories, so you know what wholes are and integers are and rationals are, who's going to win the game and why? Who will be able to say numbers from their category the longest and win the game? We're not going to take answers on this one. We'll talk about it tomorrow. But if you have a question on it, I will take that. No? All right. Remember, these definitions that we put up on our sheet today, being definitions, they can go on a help sheet. Okay? So I would advise you to start making your help sheet for Unit 1 as we kind of go along here. Okay? So you're not doing the whole thing the night before the test. Do it as we go. Mark what's important. Okay. If you have any issues with the homework, please don't hesitate to send me an email. I'll just be watching football tonight, so I have no excuse not to respond to you. But that, folks, is how you math. Okay, it's a Monday. We'll try that one again. That's how you math. Much, much better.